As scientists, we search to find paths that lead us to answers and solutions to equations and questions that initially may appear abstract.
Chlamydia is the most common sexually transmitted bacterial infection, but unfortunately, it often displays no symptoms.
Well, it was for snack, and I didn't know there was peanuts in it, and my teacher didn't know either, so I did eat one.
And then what happened?
And then I had an allergic reaction.
Formerly known as bovine spongiform encephalopathy, or BSC, the sickness obliterated UK cattle populations in the 1980s and 90s, and was responsible for the deaths of 225 people worldwide.
But for those of us who see the big picture, recognize that the most abstract questions can lead us to some of the most specific answers. Answers to problems that center on the health of the global population. We call this the human factor. This summer, we focused our efforts on designing and researching a fluorescent DNA aptamer, or rather, a nanoparticle device for lysozyme detection.
Aptamers are specific nucleic acid sequences that can detect proteins and other nucleic acids.
Lysozyme is a naturally occurring protein that can be found in chicken eggs as well as in human tears and saliva. The enzyme has antibacterial properties to gram-positive bacteria, which helps ward off bacteria that causes diseases like salmonella. Our device is designed to detect lysozyme via DNA aptamers with fluorescein. Fluorescein is a fluorescent chemical compound that emits 521 nanometers of green light when it is excited with red light. Dabasil is a dark quencher, which is a compound that absorbs excitation energy and re-emits the energy as heat. Dabasil is a weak dark quencher, but when close enough, it absorbs green light spectrum. Thus, the pairing between fluorescein and Dabasil are fitting. Gold nanoparticles are essentially very large dark quenchers. Positioning fluorescein close enough to a gold nanoparticle will cause the fluorescent intensity of the fluorescein to diminish due to contact quenching.
Historically, there have been so many diseases that have turned into pandemics. They would start out in one place and then it's a global outbreak from there. Like the SARS, the HIV, H1N1. A lot of them seem to be viral diseases, and the reason for the outbreak is because they're hard to detect immediately and contain them.
Basically, we're designing a device that would allow a person to easily test for an STD, a viral disease, or even for a particular allergen quickly and accurately in an effort to stop potential pandemics in their tracks.